All right, guys, in this portion of the video, I wanted to make this a more encompassing tutorial. And in doing so, I feel showing you the enclosure of it finished and then talking about the component you're about to see being assembled. You notice this is the IEC. We discussed this in the video of me assembling it. And you notice you have a long ground, a short ground, a long neutral, a short neutral. And then we have two shorter power leads. And these are your hot leads. You have one shorter, one medium sized. And inside the enclosure, I wanted you to see the IEC. It's right here, it's on the bottom. And then you see your auxiliary power in, and then we have our fuse. And that explains why we have these leads. Now, one question that's come up, and it's come up actually quite a bit over the years, is that daisy chaining? No, it's not. This is called a pass-through connection. Daisy chaining is when, per se, we've got our power supply here. Let's say we had another power supply. You can see how this power supply is connected. We have our ground, our neutral, and our live lead. Okay? If somebody mounts another power supply, namely a YouTube content creator, because we've seen this done time and time again, and they decide they don't want to put in a power distribution block, what they'll do is jump, like let's say this live lead over to the other power supply's live terminal to avoid doing extra work. That is daisy chaining, and that is going to get you in trouble. You do not want to daisy chain. A pass-through connection in this term is simply allowing electricity to come into the enclosure from the bottom and then pass that electricity from the bottom to the top. So we have in electric going to all our componentry and out going to whatever accessory plugs in here, and of course our external fuse. Now my systems have 3 fuses. This is the external. We have one inside the G540 and we have one inside the power supply for triple redundancy protection. So now you understand, when you look at the system, I think you can get a better feel of just how this is wired and just exactly what we're doing here and what you're about to see done. Hey guys, it's Vince. Today in this video, I want to continue doing some more building. I've actually had quite a few G540 systems sell, and I said to myself, you know what? A lot of guys have loved the SMCU series, so what I'm going to do is do a G540 series. And what I'm starting with is the IEC power input for the G540 enclosure. Now this is a 15 amp, 125 volt input. You can see that right there. We have neutral, earth, and live. And you should be able to see that in the camera. Can they see that? Neutral, earth, and live. And there's the ground symbol right there for your earth. Got our Omnivice set. We also have our auxiliary power input, same typical wall outlet input you would find in your home. And this is, of course, a female. And how do we know it's female, gentlemen? Because we have holes. Coming over here, this is a BX6B. You can see it right on it. Let's see if I can get oriented. BX6B, 15 amp, 125 volt. So this is where I start my systems. I've got all the wiring set up so I can do the initial beginning process of wiring IEC, along with tinning all of our conductors here for our auxiliary. Now, one thing I like to do, and again, this is just me, these sometimes have burrs on them, and you can see that right there. It's got a rough edge right here on this conductor. And then over here, we have another rough edge. So what I'll do is I'll hit these. I'll probably do it off camera with a Dremel to get these all ready so we can get them ready to tin. Now, why do I do that? I do that so when I'm positioning my leads, I'm not fighting with that. I also look to make sure if my ground terminal is straight. And when I say straight, if it's parallel. If it's bent, we want to straighten it. Now, a lot of guys say, well, that's kind of crazy. And I say, is it? Because if you're buying a system from whoever, I'm hoping that they would take the time to do it correctly, and that is correct. So now that that's being said, we are now ready to begin the tinning process. I already got the iron hot, Kester 186 RMA flux, of course, and we begin the process by applying our flux right to one of our terminals on our IEC. Now, I am going with more heat on this and doing 750 on the iron, and the reason I am, of course, is because this is a much larger conductor. I'm coming over and I'm just touching it. Wait a second, let that heat go. And there's your tin. Now, my recommendation is I usually do this twice. You can see the sizzle. And that sizzle is because, of course, that conductor is nice and hot. We'll come over again and just kiss it. And that's what we're looking for. And you can see that residual flux on here is perfect. And why I like a little more flux, and I've said this in previous videos, is the more flux that's on here, when you go to apply your conductors and then solder again with flux, that residual flux will once again help smooth out all of that joint when it actually meets. Again, soldering is more of feel. It really is an art in the sense that it just takes time to get a feel for the heat and the combination of speed. Once again, I'm going to the earth ground. The only reason I'm not putting this in the Omni-Vise right now while I'm doing this is because this is faster. Now you notice we didn't get transfer over the hole, and that's okay. We'll do the same process again. You'll see the sizzle. Do not overheat your conductors. If you notice the solder is not moving, don't force it. Add more flux, move on. There you go. Next one. Now, you know my orientation. Pay very close attention. Details are everything. Right now, our neutral is vertical. Earth ground, vertical, meaning my solder point is here, my solder point is here. It is not on this side. It's wherever I applied the solder. You will find that as well. That choice is yours on which way you want to go. However, on my G540 systems, that is the correct orientation. Coming over here, you can see that our live terminal right here is on the opposite side, and that is correct. And once again, I'm going to continue that same process. Once again, watch where you place your fingers, because if you put your finger on a terminal you're heating up, you can rest assured your finger is going to get a nasty burn. Ask me how I know that. So now we're doing the same process. Come in. Make sure we get good heat, and that's it. Perfect. We'll do it again. Right there. Done. Now, what you guys should be paying attention to is that finish. When the solder is cloudy, it means you've burned off the flux, and therefore you have what's known as a dry joint. When the solder has enough flux, you can see that chrome finish you get. And that's what we're looking for. Now we're ready to rock and roll. And once again, I'm going to rotate the IEC to follow the correct orientation for what my project requires. On a G540 system, we're going with our neutral vertical, our earth ground vertical, and we'll move from there. Now we've got our earth ground leads. We're going to go level 2 on our nit picks. 1, 2. Done. 2. Here we go. So now what we're going to do is merge these. I'm going to show you how we do this. Level everything. You can see if your nit picks are sharp, you're going to get a very clean edge. Everything here is nice. We're going to come in here. We're going to bring them together. Just gentle. You do not need to twist and twist and twist. I see these videos where these guys do this over and over and over again. And what they don't realize is soldering is going to, if it's done properly, weld everything together. Now watch. We're going to add flux. Merge these two leads. Once again, leaving at 750 degrees Fahrenheit. I'm going to come in. Now you notice I'm going lengthways on my iron because I want more heat. This is a big conductor. Done? You can see we burned off the flux. We stopped the process. We begin the process again, same way. Done. Now, you can see right there, we've got a perfect joint. I'm going to hit it one more time. And now we're going to just brush the iron over it with a teeny bit of solder, and it should level perfectly. Done. And you can see that chrome finish now will come in. We're going to trim the tip. And this is why. That's what you should see. Solid. All the way through. And this is why many guys' systems fail in the sense of looking at it from that perspective, making sure that every conductor is the way it should be. That's the way that conductor is. We move on to the next conductor for tinning. Once again, you see very light pressure. Come in, and we're going to do the same thing. More flux. I bring it up to my solder. Why is that? Because I've stated this in the previous videos. The solder itself has rosin flux, just not much, but why waste it? If you can put your lead underneath, you're going to get that flux as well. Done? There's your lead. That's a properly tinned lead. We'll come over, we'll trim. Check again. You could see right there, perfect. Coming in. Same thing, lots of flux. Put the conductor underneath where you're making contact with the iron. Why? Because gravity is going to pull that flux inside the solder down and give you that extra benefit as well. Done? Touch? Done. If you get any lumps, if it's uneven, more flux. Flux will level everything out. Now, I'm not adding solder because there's an abundance of solder here. Done? And that's us. That in. Look at that. Okay. So now we've got two leads that have merged to one. Everything here is set. So now we'll have our earth ground come over, and this is for our IEC. So once again, we have power coming into the system and power also coming up to our IEC's ground, and everything merges. So right now, what we're going to do, come right here, flux, flux. Find a position where you've got your hand jigged, meaning I'm making sure my wrist is against the desk. This way I do not move and sway. Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care. And any type of movement in your hand or wrist is going to be transferred to your conductor. You're going to come in. Let's see what we got. Okay, now that right there, we have solder on the joint, but that's not enough. Why I say it's not enough is you have two conductors there, two 16 gauge conductors there, and we want to make sure that we have enough solder on each side to make this right. More flux. Now you understand why soldering so much more money than doing crimp connections. See what we got. And there you go. And now you can see just how much solder is there. I can't really tell if I'm centered. So what we'll do, and this is what I recommend you all to do, I use my flux remover. Once again, citrus-based flux remover. If you guys are interested in anything you see on my desk, let me know, because of course, I sell what I use. And that's the easiest way to say it. If you want to know what I recommend, very simple. Look on my desk. That's what I recommend because that's what I use every day. So again, you can see that lead is dead on. We're golden. So what we're going to do, we have a little more solder there, and I'm going to spread that out by heating this a little more. Come back in. You notice I'm not killing my clamps either. I'm just making it so everything is held perfect. We don't need to go crazy. Teeny bit of solder. Now, whichever way I want to move, I move the iron based on which side I want to move over. Golden. Now we clean. And you've got a perfect joint. That joint is solid. You can see everything right there. We're perfect. We have enough solder on each side that signifies we're golden. And that's why, once again, your resistance is lower because you can see all of that conductive material, which is the solder, and that once again with ground is exactly where we should be. If you look at these conductors, you will also see that they're parallel, meaning that they're going straight. We shouldn't be twisted either way. So again, details count. Move up, same principle. Go into neutral now. 16 gauge full copper core leads are what I'm working with right now. Once again, orientation is important, meaning which lead am I putting on the top or which lead am I putting on the bottom? Put my small lead on the top because it's a jumper. I put my large lead on the bottom. You can see how level we are. Bring them in. Easy. The main thing is stay level, as level as possible, because again, when you go to solder, we want to make sure everything is just in place to once we apply our solder, we're golden. Done. Tools out the way. Come in, same thing. Conductors on the bottom, iron on the top. Bring it in. Got a puddle, touch it. Done. Come in. Flawless. If you do not cut the ends of your leads, you are guessing if you have full penetration. And ask me how many times I've had guys ask me that question. Why do you cut the lead? That's why I cut the lead. I don't guess. I want to make sure it's done right. Done. Now you will find, the more you do this, that naturally you get better at it. You can judge things as far as whatever you feel is fit. Once again, my work is being presented. You buy a system, you expect it to be done correctly, and for that extra second that it takes to do, we do. Perfect. And you notice I never fight the leads. Everything there is set perfect. So we're going to come in here and we're just going to go right there. And that's us. Now, let me flip this upside down because I almost made an error. We don't want the long lead on the top. We want the short lead on the top. So once again, orientate everything. If you have to, you can heat the leads to make it easier to manipulate. So right now we're golden. You can see the abundance of flux we have. We're going to put more solder on. That's a dry joint. And once again, we're going to come up. There we go. You could see the pocket on each side once I clean it. Nothing fancy, guys, just some Q-tips, citrus-based flux cleaner, and you're in. You can see that joint is fully saturated. That looks great. There you go. Check your back. You should always be able to see that your conductor's casing is not burned or there shouldn't be separation. Everything should look symmetrical. We're just trying to heat where we're trying to heat and apply that heat naturally so that we can get that solder where we need it. Any additional heat that does any damage, that's a no bueno. So again, we pay attention to that. We have a, this is actually going to be from the IEC going over to our fuse. In this case, we're just tinning this lead, so we'll get this knocked out. Just let that iron heat up. Once again, conductor on the bottom, iron on the top. Let that solder's flux just flow. You get that little tail. See that? But we still have a lot of flux. Watch. Done. And I'm doing it quick. And the reason I'm doing it quick is I don't want to burn off my flux. The more you burn off your flux, you're not going to get the leveling effect you want. So therefore, if you have more heat, use more speed, because more speed dictates you're not going to overheat. Use less heat, then naturally use less speed. Feel is everything. You're not going to read this in a book. Same principle. Done? Tail? Done. Done? Perfect. Good? Done. Two more conductors. We have a long one and a short one. And this is to jump over. Once again, this will complete jumping over to our IEC. Level everything up. Right in. You can see how our copper is. Everything is set. We're level. You can see right here, we're level. Come in. Once again, conductor on the bottom, edge of flux. Iron come up to temperature. When you clean, rotate the iron. Done. Actually, this is a lot, so I'm going to add a little more flux. Perfect. One more take. Larger conductors will always require more flux. It's the way it is. Teeny bit of solder. Done. We go. If you're a person that is uncertain of damage, meaning you may overheat something, your hands are not as quick, you don't have a feel yet, always use less heat. Once again, my experience, just by doing this every day, allows me to play with things a little differently. So we adjust. There's no rules other than practice. Done. And what we're looking for, you can see that conductor. Once you got chrome, you nailed it. A little bit more. Perfect. Okay. Done. That's great. Sure, want that one more time. Good there. And good there. Perfect. Now we're going to come in. Once again, I'm straightening out my leads, and I want the small lead to go to the top. So this will be rotated like this. This will then make conduction this way. And once again, when they're tacked in place, we have our small lead going to the top of the IEC and our longer lead going to the bottom. Move my garbage out the way. Oh, we got some. Let's see what we got. Load it in place a little bit. Good. Check. Once again, we're a little dry and we're a little low. So I'll just move that over, but you can definitely see the joint is set. So now what we're going to do, same process. And you guys will learn a feel the more you do in building. How your heat is working, how the solder is working, and you should be able to tell a good joint from a bad joint very, very quickly by what it looks like. It's the beauty, you know, that you can reheat carefully. As long as you have flux there, you're good. As soon as that flux burns off, we're no bueno. That's flawless right there. I'll clean that up, but you can still see the abundance of flux right there on the bottom. And that's exactly what we're looking for, just a symmetrical conductor. Matter of fact, I'll put this on camera for you so you can see it right there. That's what we're looking for. That's what we're looking for. Flux removal. Now, once again, the Kester is no clean flux, but I like cleaning it because I like looking at that, and my clients would expect that, and I would hope you'd expect that. It's just the way it should be. There you go. That's a proper joint. If your joints don't have that chrome finish, they're not clean. That's what that tells you. You can see that. They all have that same finish. These are set to go. So now what we're going to do, we'll move the Omni vise out of the way. Don't need that. And what I'm going to do now is just apply my heat shrink. Everything must be insulated. So no matter how good your soldering is, if we are not insulating, we have a problem. Okay? So we come over here and we apply this. Once again, I'm just going to hold it down, turn on my precision heat gun. That 6 mil heat shrink, done. This one. Now I like to do one at a time. Some guys will put the heat shrink on all at once. Problem when you put heat shrink on all at once is you're building a bad habit in the sense that if you're doing close proximity soldering like you see here, and you have all these pieces of heat shrink very, very concentrically close, what you end up usually doing is inadvertently heating other pieces, and that could actually land you into a problem if you're not meaning to shrink it at that point in time. So just keep yourself aware of that. And I'm always manipulating the leads with heat. So wherever I am, I'm paying attention that if I can keep these leads straight, I'd rather shrink straight than have any problems. And now we're golden. You can see those two are set all the way to the base. Nothing exposed. Coming in again. Boom. Come in. And that's us. Now we're going to come in and do a final clean. on our IEC. I always do that on the back just to make sure, because you're going to get some splatter from the flux. I like dealing with clean components. That's me. Everybody's different. But now you can see what we have. There we go. Once again, the back of the unit, nice and clean. All of our joints are set. Everything looks good. Conductors are good. You can see how level everything is. And that's exactly what we should have. And now, all I'm going to do, and rather than bore you, because I'm just going to do the tinning process on the auxiliary, is I'm going to deburr these, make sure they're good, and I'll do that with the Dremel tool. And then I'm just going to apply some flux and some solder and just get them ready to tin. And that completes this episode of doing the IEC for a G540 system. Hey guys, it's Vince. Today in this video, we are continuing with the G540 system build. And in this video, just like my previous one, I'm showing you the finished system, and where we are working on today will be the Estop switch and of course our power switch. And these are the assemblies we are working on. This is the shielded Estop cable. And once again, this does have a shield drain with ring connector, and we do have our 20 gauge silicone leads going within tin braided copper, properly insulated them with heat shrink, and then our power switch. Okay, so just so everyone can see, here is the Estop cable attached to our Estop switch. It then comes back. We then have our ring connector that is installed within our power supply's mounting lug. So the nut that mounts the power supply also allows this to properly shield drain to our enclosure. Now, to prove this point, because I still get tons and tons of questions on grounding, here's my fluke. I'm going to turn it on. Right now we're just going for continuity tone. And Joanna will film the power supply, and I'm just going to hit the ground lug, and you can see we are grounded. Okay? Now, if you guys look at that multimeter and you see 1 or anything 3 or under, you are properly grounded. I'll say that again. Just because you have continuity does not mean you have a grounded system. You are looking for 1 or even lower. The lower the better. Now you'll notice I'm hitting the ground lug, and I'm also testing, and I say the ground lug on the power supply, because the power supply is conductive to the enclosure, and therefore it grounds everything. Come here, we'll test this. You can see everything is grounded as it should be. If I come over here to our auxiliary, everything is grounded. Okay, so that's the difference when you're looking at purchasing a system. These are the questions you better ask if you're buying one assembled and you don't know who you're buying it from. That is something that is an absolute must. The system must be properly grounded. Now you've seen exactly how the power switch is. It comes over here. Now, of course, we only have 2 leads on our switch right here because we have to install this in the front plate, and then we'll wire the other 2 leads. We'll be doing that shortly in the next video portion. But now we'll go over and I'll show you exactly how we begin wiring. First of all, building the Estop cable and then wiring the power switch. You can see I have all my leads laid out. I've got my shielding laid out, and this is tin braided copper. I have my heat shrink for my tin braided copper. I've got my Estop leads here. These are 20 gauge silicone. I've got my 16 gauge leads here. These are for my switch, which is for power. You can see it's already mounted up on our Omnivice. And then we have our 2 leads here, which will power the G540, which are 18 gauge silicone. Over here is our stay put. It's holding our ring connector. And what I'm going to do first is we're going to work on the leads that do not require assembly. These just require tinning. So I've got the soldering station already turned on and powered up. Everything is good there. I'm adjusting my Nipix auto strippers so that I have them set to the minimum, which is approximately 6 millimeters of what's actually being stripped off, so that I'm getting to the conductors. And now we'll begin the process of applying flux and solder. Now, once again, I come over. Actually, I put a little too much flux on that time. It actually dripped. Clean our iron. Once again, I put the conductor underneath the solder so it can incorporate the flux from the solder that's internal, along with the flux I'm already using. Let this just heat up and you'll see a big blob is what we're looking for. Something like that. Perfect. Now we add more flux. Do that. Cleaner tip. One more time. Like I told you guys, you really don't have to worry too much. If you put too much solder on, all you have to really worry about is how much flux you apply then to that conductor, because what will end up happening is you can clean it and level it by just applying heat back to it when there's the proper amount of flux. It will just level itself. And there you go. Now I'm going to trim it, just like we did the other leads. You can see that's perfect right there. Going to the next. Now, in my last video, I got asked, why do I prefer soldering instead of crimping? And all I say to you guys when you ask questions like that, any precision electronics you purchase, is it soldered or crimped? Think carefully of what I just asked you. All your cell phones, your motherboards, anything that requires precision is always done with solder. Now, there are different methods of soldering. What you see me doing with the flux and the solder is the correct way to do it. That costs the most to do. And it's not nearly as fast as crimping. And that's why we see so many crimps, is because that is the way traditionally most people will do things in terms of trying to get done quickly. They're not looking at the fact that a connection done with solder and flux will yield a much more conductive, low resistance connection. And this is fact. Now, why is that? It's because the solder will fill up all of the conductors. And how do we know? Because if we cut this terminal again, you can see that solder has filled all of those conductors. Now, if this was just bare and not soldered and put inside a crimp connector, you'd still have bare leads. So the more conductive surface you have, the lower the resistance. On top of the fact, you are welding essentially. This is conductive welding. That's exactly what you're doing. So most people already know, but I'll tell you anyways, if soldering is done properly, it's forever. Crimps I have seen over the past end up with broken conductors or broken connections. I've had that happen numerous times from clients over the years. And I'm not saying it happens all the time. I'm saying that crimps, basically that's whatever's out on the market, those are not precision instruments. You don't know how much pressure they're putting on your conductors. So I recommend, if possible, and if you're willing to learn how to solder, and you will not look back. It will take you more time. And that's why most guys don't do it. You won't see content creators doing it. And the ones you do see doing it usually are doing it wrong, because they don't even purchase the proper flux. And therefore, they're just using what's inside the rosin core solder. We don't want to do that. Everything we're doing here is done the way I would do it for myself. Hopefully you would do it for yourself. And that's why I do it for my clients that way. You see every connection. We start with flux, staying lengthwise on the iron, once again for maximum heat, and then I just drop it, and you can see that ball of solder. And you can see how chrome it is. Once we hit this, that flux will work and do its job. We still have a little more solder on that side. We'll level it. It's all about working with your tools. And there you go. So the question now that I would have to anybody is why you wouldn't solder, especially when these systems you're hoping to build forever. Even if you decide to upgrade or sell your system at one point, you know it's done right. Once again, conductors are all bonded. Everything looks great. Come over here. This one actually has a slight little bubble on it. I'm going to take that off. It's not a big deal. All we have to do, same principle. Done. That's how fast Remember, flux is not an option. It is a tool that must be accompanying anytime you solder. Okay, those are done. Now we're going to go into the assembly of the shielded E-stop. Now, a shielded E-stop leads. The thing I want to point out is, technically speaking, it's up to you if you want to shield your E-stop leads. I prefer to do it. And I do it for all my systems with a shield drain. And I do it with 20 gauge silicone leads, tin braided copper. And you can see this is tin braided copper, also known as ground strap. It's 1/4 inch. And then over here, we have our heat shrink to, once again, encompass this piece of tin braided copper once everything is done. We'll cover that real quick. So we're taking our 20 gauge lead for our shield drain. We're going to take both ends off as far as the casing. This will be terminated to the base of the power supply because we know our power supplies are conductive, as they should be, and your power supplies should be as well, if they're built properly and if they are grounded. You want that power supply to be grounded and you want it to be conductive so that that conductivity will follow suit and ground your system using a proper electronics enclosure. Done there. Now you notice I'm not cleaning this. And the reason I'm not is because this is going to be joined to our tin braided copper in order to be a shield drain. The term drain is going to be used to drain any potential EMI right off of that tin braided copper to our ground. Okay. You notice I'm always going for a lot of solder because as soon as I hit this with the flux, it'll cook it and you're in. Done. Now we're ready. Now I'm going to take one end, and then this end I'm cutting it a little smaller because I do not want it to exceed, I don't want the conductor to exceed where the ring connector ends. So right here, I want this to stay within this metal casing of the ring connector. I don't want it to protrude out. So now what we're going to do, we can come over here, little flux, little solder, capillary action, chase it right in. There you go. Nothing to it. I see guys fighting these type of connections all the time. We don't need to do this. As a matter of fact, fill this up again. Come in here and hit this. We'll come right over the top. That's why I stay put. And all my tools are necessary because then you can see that flux. There's absolutely no way I'd be able to hold everything and jig everything. Everything has got to be held perfectly in place so you're not messing with anything. And that's perfect. Now, want 3mm heat shrink. That's going to come up here. I'm going to finish this end. Well, done. Heat shrink. Done. That's done. And that is a ring connector that the power supply's mounting bolt will go through and once again attach to the base of the chassis, meaning the electrical enclosure, henceforth grounding it. The shield drain I'm talking about. So now we're going to go to the leads that will make up the E-stop switch leads. Very simple. Same process. Let our iron heat up. And once you get that ball of flux on your conductor, you can see it's just got a nice coating of flux. That's what you want. We're going to go to 750 on this. That color. Actually, you know what? No, I think I'll stay at 650 because we're at 20 gauge. So let's see. And you can always turn your heat up. I suggest starting low and then turn it up as required. Done. Yeah, that looks nice. Done. And perfect. Once you guys get a feel for soldering, and once you get used to assembling with soldering, many of you will not ever go back to crimping. First of all, you're going to find that everything is done for life. There's no other way to explain it. Crimps do last a long time if done properly, but like I said, there's such variables when it comes to crimping tools. These are things that you need to pay attention to. Guys are buying these ultra cheap crimping tools that they find on Amazon, and many of them have no quality assessment as far as pressure, and then you run into problems. These are done right. Let's check this. And there we go. You can see those are perfect. Okay, moving to the next one. And what I was speaking about with the pressure from a crimping tool, if the crimping pressure is not properly calibrated at the factory, you will have broken conductors, and those broken conductors can yield faulty connections. Ask me how I know this. I can't tell you how many guys I've worked with that I've seen that off. And it's simply because either they didn't know how to solder or they didn't want to deal with soldering. And that's the truth. Okay. Same principle. Okay. Same process. If you still see that puddle of flux, you can keep feeding until you don't see that puddle anymore. And then you go. That's when you know your flux is burned off, because it's no clean flux. You will notice the longer you apply heat, it'll keep virtually getting clearer and clearer from that amber color, letting you know that it's gone. There we go. Okay, so we have our conductors now for our Estop. And on my systems, I have one long conductor and one short conductor. Now what we're going to do, we're going to take our tin braided copper. I get this question a lot. How do you make a shielded cable out of tin braided copper? Very simple. You got a glass stirring rod from a chemist. And you can pick these up online. Anyone that does chemistry or does stirring, these work great right in. That opens up the tin braided copper because we do not want to have frays if possible. And now what we're doing is I'm correlating these leads in the configuration I require for my system, which is the short lead on the inside, long lead on the outside. Now what I'm doing is once I've got them all set, I just insert these into the shielding. Now you can, and I've gotten asked this question a lot, you can do this yourself. Meaning you can build a shielded or even a double shielded cable. Double shielded cable, all you need is another piece of shielding over this. Typically mylar foil would be best. But this does not require maximum flexibility. It's a straight wire run. And I have guys that'll say, why don't you use your double shielded cable on your 20 gauge? I'm usually quicker to do this, just the way I do it. And this is a little more of a straight run. I like a straighter run in this application because sometimes cutting the casing is not always the fastest. This is a little quicker for me. If you get any frays, get your probes, use them carefully, and just pick those frays and you'll be set. So I've got the proper amount of leads coming out, a little bit of flux on there, no big deal. Now we're going to turn our stay put 90 degrees. Come in. Now you see how the stay put works, and we've got all this beautiful tin braided copper right here. I'm just applying flux to. Now tin braided copper, of course, is copper and tinned. So all we got to do is apply solder right to it. Just wait. This is a much bigger conductor. So I'm just hitting it. Done. Now I'm going to turn my iron up in temperature because this, like I said, is a much larger conductor. We want this to be seated. Silicone leads will not burn very easily. You should still pay attention to the heat, but these are much more reasonable when it comes to applying heat. Now we've got a nice tin there. We're going to come over here, apply some flux on our conductor for a shield drain, and just come in here. There's your perfect lead. Done. So now we've got full conduction here. That weld is set. Everything is good. Lift. Now you can see exactly what we've got here. Let's move our stay put out of the way. And once again, we want to hold the correlation of the leads, or I should say, I want to hold the correlation of the leads. If you guys are building your own system, it really doesn't matter what you do because you know how you're building it. On my particular systems, I want to hold the correlation of the leads like this. And then what I'm going to do is feed the heat shrink now over this, completing the assembly. Okay, so now feed this up for about the same even connection. Come in like this. Now what I do is apply heat because I want to lock this in place. Using the precision heat gun, very easy to do. I'm not burning my fingers. I recommend you guys all use the heat gun that comes on a soldering station. And if you're serious about learning electronics and working with electronics build-wise, you are going to want a soldering station. At one point or another, believe me, you'll get tired of working with typical irons. Now that's all set. Now I'm going to do the same thing on the bottom. And the reason I'm doing that is, once again, I want my leads to be locked. I want these to be in the same position that I have them right here. I'm just going to come over here, feed that up, then we'll shrink this in. We're feeding it. Once this is set, we're good. Then I'm going to hit it with the larger heat gun because we already have our positioning on our leads. And this is why I say there's no...
Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care.
There's no manual for this. You have to learn doing it. Large heat gun now. Complete the process. Hand low position, hand high position. You want to make sure these leads don't move. And now what I'm going to do is start from the top and just feed it down. Kind of like building a spindle cable if you've watched those videos that I do. Straighten as we go. Watch your fingers, you don't want to burn yourself. There we go. Nice and clean. That's us. Clean these off the flux. And that's about it. There's our Estop cable. And you can see shield drain, 2 leads. Done. Once again, you guys can do this in your own systems. It's up to you when to apply building a cable in the sense of something custom like this, or incorporating the proper cable that's already pre-built. That's totally up to you, the end user. Again, for my system applications, this works amazing. Now, 2 left leads, or I should say 2 leads left, and these are going to be to build or hook up to our switch. Clean up your desk a little bit. I just work better that way, mentally. Omnivice set up. Just figure out which way I want to go with it. We're good. This right here, KCD4 switch, 15 amp. Right here at 250 volts, 20 amp at 125. You have 1, 2, 3. And then you have nothing on this side. Okay. I get questions on how to wire these all the time. So these questions will be answered as we go through. First, I don't think I'm going to chalk it up in the vise. We'll do the tinning. Very simple. Apply your flux. Boom, boom. Get your solder all set. Turn the heat up. We have a larger conductor now. You can see this, the spades that these have. So we're going to turn the heat up, 750. That's degrees Fahrenheit. So we can conduct heat properly and get these knocked out. Done? That's what you should see. Apply a little more flux on this one. It's a little dry. Perfect. Now you notice I'm turning the switch upside down. I'm doing the other side of the spades on the back side. And that I'm doing because of the way the switch will be orientated once it's mounted within my enclosure. One I'm done there. Should be good here. Done. You can see, perfect. Perfect. We have everything filled. So now we want to orientate the switch properly in the omnivise so we can attach our leads. Right there. Done. You'll notice I've got the two vices set up differently. I have one arm at basically 90 degrees and one vertical, depending upon how much height I want. This is actually a little high right now. I could use that one, but we'll see if I can pull it off. Once again, pay close attention to the numbers on the switch. They correlate to what leads are going in. Now, number 2 position on this particular switch is going to be the out of power, meaning you'd want a red lead. Going in would be a black lead. Going in on the other side would be a neutral, because neutral, once again, is what's controlled with these switches. So we have power going out, and we have a neutral going out and a neutral going in. That's all that's connected to these switches. So now what I'm going to do, set my Nipix up, 1, 2 clicks back, approximately, it's about 7 millimeters. I'm out. I always get asked about the 16 inch. You can see the copper. So we come over here, real gentle. Feather them in. Let the iron heat up. Now we are using larger conductors. Once again, 750 still on the iron. Done. Right there. We do not want to clean flux off of this side, because, or I should say any one side you pick, because you're going to apply it once again to that terminal on the switch. You can see right there that conductor's perfect. You notice no burn casings because everything is done quickly. Done. Done. Perfect. Take the tip off. Like trimming a cigar. There you go. Perfect. So once again, one end we don't have to clean. One end you should clean, because one end will be used for power supply connection. Down there. So this end will be terminated. Just double check. Always double check your switch position, number 2. And number 2, once again, the number 2 on this switch is going to be your power out. And therefore, that's why it's red, because red would signify live on our power supply. So I'm going to come over here, add some flux. I'm going to add some flux on this side too. Ain't going to hurt nothing. And you can see there that flux is sitting there like a pool. You'd want to keep it more like a pool, because the more condensed that flux is in one spot, it's going to burn off slow, which gives you an even better smoothing effect and also make everything nice. So you'll see how we're going to terminate just like that. And the thing to keep in mind, guys, is I've been working with this for a long time. You want to practice, and you're going to notice real quick, if you're not ambidextrous, it sucks, because then you're trying to solder over components. But I've soldered lefty, taught myself how to solder lefty, because you have to. Sometimes you just don't have a choice, unless you're looking at where you're going to be as far as, once again, being on components. You take a peek. Okay, you can see where we're off. Got a big gap. I'm going to bring everything in. About the same position, just moving it up. So again, soft hands here. No ham fisting. Everything is delicate. But you see that flux work perfectly with that pool. That pooling effect is what we want. You back up just a teeny bit, because I need to be able to get in there. Come in. Adding a little more solder. And that's why I say jigging everything, your hands included. I did not move. Right on. Everything there looks flawless. So now I'm going to clean it. We'll see what the connection looks like. That's why we use good flux. And I have found over the years, Kester is the best. And that was when I decided to sell it myself, because once I seen how it worked compared to the other stuff on the market, I've used MG chemicals. I've used a lot of them, just do not work. Not the way that I feel flux should work. Look at that connection. Beautiful. There you go. That weld is totally symmetrical. Right there and there. Perfect. Check our bottom. Casing is beautiful. That little flux there. Come over here, clean it. And that is what we want. Nice and clean. Okay. Moving right along. Done. Good. Right, guys, we're just going to do our neutral lead now. Same process. Let it heat up. I'm actually connected to the solder right now. Get that off. Up to it. The other end. Perfect. And I've said this in previous videos, guys, always try to keep your conductors straight. Much easier to work with straight conductors. That one will leave. Okay. Right there. So now I'm going to come in. Much easier to work. You notice I started on the hard side in terms of me having to solder lefty. Now I'm coming over here. Once again, like I told you, try to keep these terminals straight. If they're off a little bit, just take your pliers carefully and sway the lead whichever direction you need. They get nice and straight. And now you're batting 1,000, son. All right. Let's come over here. Right there. Okay. Okay, same thing. We want to come in a little bit. It's also a little less solder on that joint. Bigger terminals, I always like to hit them twice. That's my own personal preference. And once again, try to keep that switch level so you get that pooling effect of the flux. The more you work with components, you'll find out it's the best thing you can do. Is that looking good? Let's see where we're at. Let's clean it. Look at that beautiful flux. That's exactly what we want. Clean that off. And I did not say it, but I didn't think I needed to, but I will say it anyways. All of the components I use, all of my tools, I offer in my store. So guys, check out my store if you want to use what I'm using. And again, I only sell what I use. This way we know that everything looks right, like that. Nice conductors. Those conductors look great. Now, if you get any conductor where you notice that your casing may not be fully seated, warm your casing with your precision heat gun carefully. And now you can maneuver it very easily. Done. Do the other one too. Very easily. There you go. Perfect. If you notice they pull back a little bit, just hold them until the heat cools down a little bit and you'll be golden. These look great. Check bottom. Everything looks nice and clean. We're good. Now, clean up a little bit. On device put away. Get our two 4mm piece of heat shrink. And I always look for the cleanest cuts, sharpest edges, because we know that our base is flat. Now, best practice, I'm not going to put these on yet. I'm just going to feed them on the conductors. And the reason I'm not going to put them on yet, I want to know if you guys know in the comments. You should know. We're going to test the switch because we never take for granted that even though it looks right, doesn't mean that switch is right. Now, you could always do this prior to even going forward and doing the soldering. It's totally up to you. Component failure is very, very, very minimal in terms of the component itself. Typically, if it was going to fail, it fails with too much heat on the conductors. And I've had this happen myself, and I've had my clients also tell me that as well. So once again, we're just coming over here to hear tone, continuity, and we're going to come over here to any terminal. This is, once again, our neutral terminal and our other neutral terminal. So now we just take one of our probes and come over here and make contact, and we turn this switch on. We should, if everything is done properly, hear tone. That's good news. Done. Now we're going to switch the switch on the other side. Same principle. It's irrelevant on what probe you use. And the reason we're doing this is to make sure we don't have any false positives, in the sense that we're hoping everything works. There you go. The golden. Okay. So now our switch is completed. We know it functions as designed, and all we have to do is apply our heat shrink for safety. And we're doing really well. So once again, I like to always expose the writing on the heat shrink. That's just something I like to do. Done. Heat it up. Done. Now again, whenever you apply heat to a component, in best practice, it's always better to use a precision heat gun so you're not just dispersing heat all over that component and cooking it. There's only certain areas of this switch that should apply heat to, and if you're applying heat just in general everywhere, and I've seen that, you've seen it, I've seen guys use lighters to heat shrink. Guys, use your head. Use your head. That's ridiculous. And for the cost of these components, if you can't afford to do it right, then don't do it. Save until you can. Save the hacks for a process that does not require this type of precision. Okay? You wouldn't want the doctor hacking on you if he's doing surgery. It's the same principle. You apply logic when you can. And now we're good. There we go. Switch is done. Subassembly is now done. We'll clean it. Now, you'll notice I have two more terminals here I did not connect. Why? Because this is not installed in the front plate of the system yet. Once that happens, because we are soldering, which means it's permanent connections, then I will solder those two leads, which will once again be a black lead, which is power coming into the switch, and then the red lead carries the power out of the switch when the circuit is open. And then we have a neutral on the bottom that once again passes neutral through the switch and applies our neutral then to our power supply once connected to it. And that concludes this build portion of the G540 system. Hey guys, it's Vince. Today in this video, we are now going to wire the front and the back plates of my enclosure. So what we have here are IEC power input, our auxiliary power output, and we also have our fuse mounted, and this is the external fuse. Over here, front plate, got our power switch installed already and our Estop. Now, of course, I did this stuff off camera because this is very logical in the sense that nothing is special done here. Everything is already milled out in these enclosures. So again, all you're doing is inserting these components and you're set to go. And you can see exactly how the sub-assemblies are from the previous assembly of actually doing the soldering, and that's the way I do them, because now I can join everything and we will now attach through the soldering process our front to our back plate. Okay, E-stop cable here, and then we have our IEC power, and this is the lead that will be attached to our fuse. So the first thing we're going to do is go over, make sure your soldering station is set up. Mine is already set at the typical 750 as far as Fahrenheit. I should say 750 degrees Fahrenheit. First thing we're going to do is we're going to look at our ground on our auxiliary. And you can see we have some leads here. So we organize our leads, and our ground port, or I should say terminal, is right here. The first thing I always do is make sure that this terminal is horizontal. If it's bent at all, I will straighten it with a pair of flat nose pliers. And in this case, it is already set to go. Here is our ground lead, and you can see that it comes over here perfectly. We already loaded all of our conductors with heat shrink, so we're set. I'm just going to bring my light over so I can see. And I doubt she's going to be able to film me tacking this into position, but she will get to see it when I'm done. Good. Do our saturation process. Move everything out of the way. Now this light is really cool in the sense that when I lift this flap up, of course it's got a magnifier, but that magnifier gives me a light. It amplifies the light from above, and then I'm able to see it a lot better. Clean my iron, already got the fan going, everything looking good. Okay. Just analyze this a little bit, see if it looks straight, and I believe it does. I'm going to hit it one more time, and I usually do at least 2 touches with the iron, and I just do that, make sure perfect heat is on there. And you see just how quick this is. And that's us. Okay. Lay this down. I can clean that terminal. Once again, citrus-based flux cleaner. Get this nice. You notice I'm rotating the cotton swab this way, and you can see it's already formulated a kind of a cone tip. And that way, we stay nice. I'm going to do the same thing on the other side. Once again, you will learn to become ambidextrous as you stay with this. The more electronics you build, you'll find out very quickly when you're soldering components, especially, having the ability to use both your hands is just a matter of time. Okay, we're good there. We're going to hit the bottom, make sure we're clean. There we go. Perfect. Let's see what we got, if I can focus some light on there. It's just hard to see. Let's see if I come in there a little bit. Can you see it? Can you see if I... Yeah, there you go. Right here. You can see that terminal buried. Perfect. Come there real quick. Just hit that conductor. There we go. Perfect. We're all set on that. Ground is set. Now what I'll do, move our light out of the way. Take our heat shrink, roll over. Right in. And again, I'm using 4mm heat shrink. And I've stated this in previous videos, but just so you guys are aware, I do, of course, offer the pre-cut heat shrink, exactly what I'm using. So this will save you an inordinate amount of time having to cut it, trying to get it to the right length symmetrically. Once again, using the precision heat gun here because we don't want to cook all of our components. And we only want that heat placed where we want it. You'll notice I hit everything with the heat, especially the conductor. When I say the conductor, I'm talking about the lead in particular, because again, I want this lead not to be under stress. So when I heat it, it molds basically right to where we're going. And you can see exactly what I mean. Everything there looks perfect. We're set. Now, question I always get asked, on the auxiliary power in, which is the hot terminal? If you guys know, I'd like to hear it in the comments, but if you don't, it's right here. It's the smaller vertical position. So you can see we've got a long vertical position and a small vertical position. Hot is always the smaller vertical position. We have our ground terminal and we have our neutral. Over here, ground, and you have your live and your neutral. So again, over here, the thing to keep in mind is matching everything in corresponding fashion. So you have your ground, live, neutral, live, ground, neutral. Once again, live, ground, neutral, live, neutral, ground. Okay? And of course, our fuse is always live because you're just passing power through it. So where one lead goes in, one lead goes out, and the fuse is there in case power has to be cut because it exceeds the capacity of the fuse and it blows the fuse. Very, very simple process, one in which you must learn if you plan on understanding how to wire one of these systems. So now what I'm going to do, and you can see our terminals now are all tin because we did this in the previous steps. So now what I'm going to do is I'm going to wire in the hot lead going to our auxiliary. And this is where learning to work, and there's no real fancy way to do this other than the fact of practice, of what works for you. Now what works for me, try to get light on there as much as possible. I want my conductor to be relaxed, and in this case it is. You can see how perfect that lead matches. So now what we're going to do is going to come up here, same thing, flux. And the more I can keep this in a horizontal fashion, now trying to keep my fan blowing over here as much as possible. I'm going to tack it into place very gently. That's one. Now what I do is I rotate this to let me see if I'm symmetrical as far as being even on my conductor. I always try to center my conductors. Okay, so we can see that we're basically centered. I'm going to come in a little more, but it does look good. If you get more of a blobbiness with your solder, what would you do? Like to hear that answer in the comment. If you're paying attention, you should be saying, all I do is add more flux and apply the heat again. And that's it. Because the more flux you add, the smoother your conductors will be. Just put a teeny bit of solder on here, contact solder. Right there. Very, very quick. Coming in, see if we're level. It actually looks pretty good. Let me wipe that off and I can see it a little better. Once again, you notice I'm going with the terminal, meaning I'm not going against it. I'm not rotating this way. I'm rotating backwards. So we do not disturb any of our casing. Everything there stays nice and neat. Oh yeah, that looks nice. Not bad at all. Checking to see if we've got even. That looks very good. Let me see in this light. Okay, we've got a missing piece of solder on this side. I don't know if she can see that. It's right there. It's not as symmetrical on this side as this side. So what I'll do is apply more heat, more flux. And as I apply more heat and flux over here, it should fill itself up and we'll be golden. You see me turning down the conductor. I'm moving it backwards because I want it to pool up as much as possible. Come on this side, got plenty of flux there. Done. That's us. And you don't have to press with the Q-tip. I've gotten asked that. You use a lot of pressure, and I really don't. I mean, you're just letting it make contact with it and let the solution do the work, and you'll be fine. Oh, yeah, that's excellent. Come right in. Perfect. And you can see that conductor now is full. Everything there looks nice. Clean it off. Got a little flux right on the corner there. Comes right off. Perfect. Come over here. You can see where our casing meets up with the terminal, as it should. Everything here is on the money. The cleaner, the better. Now we'll just come in here and you can see how perfect that lead's length is. I always look at that because it should be in that corresponding fashion. The lead is not under any stress. You can see that right here when we look. Everything looks right on the money. So now what we'll do, once again, same process. We're going to apply our heat shrink, just roll it over. In this instance, on these leads on the top, when we're doing auxiliary, I always put the lighting to the top. Precision heat gun, just come in. I'm up here again, and I'm just heating that conductor, meaning the lead, so that this is in a relaxed state. There we go. So now we're going to go with our neutral, and then due to neutral, we're going to come in, and look, I come underneath. So the wire actually will come underneath, and in this case, you can see I'm on an angle here. So I have a choice. I can come down here and knock this out on this angle. I'm going to go right there. The more stable your hands are, the better your jigging is, the better the joint is going to be. It'll look much, much better. You notice I pulled the iron away before that flux was all gone. Now we're going to do the same thing. I come up here, and you can see how perfect that looks. I'm going to add a little more solder. You can see it's tiny bit dry on the edges. We'll just add a teeny bit more solder. That's why I always do usually 2 kisses, and we're golden. And then again, nice pool of flux. Clean that tip. No one likes a dirty tip. We're golden right there. Wipe that off. Once again, following with the conductor. I'm not going against it. I'm rolling this way. And then this way we know we're good. Let's come up. Much easier to see, and you can see exactly what we have. We'll check our angles, make sure that looks good. Might want to pivot that one more time, meaning I'm going to angle this lead slightly up to be against the conductor. Do that again, and that's why I always clean, because I cannot see everything as clear until we are immaculate. So we'll be immaculate. A little more flux, a little more solder. Hold it with my face. I know that sounds funny, but I used to do it a lot. Right on. Oh, yes. Right there. See that? Perfect. And you do not need to waste your tools. And when I say your tools, anything that's consumable, you notice I don't sit there and spray every single time the flux remover. Once the Q-tip is saturated, you can use it 3-4 times before you have to respray it. Don't waste anything. Big believer in that. Clean. Beautiful. On the money. Okay. Check the back. Make sure that looks pretty. And you see, every time I go against the grain, it'll lift the Q-tip. But if you go with the flow of how that terminal is terminalized, meaning the angle at which it's placed on the conductor, you're never going to have deterioration of your Q-tip. It'll last for quite some time. And that's what we're looking for. And if we look at the back, it's immaculate. That's how we know we use the proper amount of heat. Casing is not degraded at all. Everything looks flawless. So now we're going to come in. Did you get it?
Yep.
Okay. Now we're going to come in. And we'll do this. Apply heat shrink, do our insulation. Using a tiny bit of pressure by my fingernail just to make sure that it's bottomed out. Do that. Precision gun again for the same purpose. We are not dispersing heat all over the place and just unnecessarily heating everything. We're not using a lighter. We're not using a match. We're doing it right. We're doing it the way the client would expect it to be done, or you, if you were to purchase a controller from me. Done. You notice any dirty spots on your leads, just hit it with the flux remover. It's totally fine to do that, and it will remove anything you find, and you can see what you're left with. Perfect. You look great. Okay. Conductors are already set. We have our fuse now we're going to wire. Now you notice I do not have the fuse installed. In the comments, I'd love to hear why you think I do not have the fuse already installed. I'm going to tell you now why I don't have the fuse installed. The fuse holder works on the premise that it's spring-loaded. So when you insert this and rotate it into the fuse holder, it's going to put pressure on the back of the fuse. Well, naturally, when you apply heat and combine pressure with heat, you have the possibility of fracturing the casing. So do your soldering, key tip, do your soldering of your fuse holders when there is no fuse installed. And you notice that gold tint to the fuse? There you go. That's what it is. So when you guys take everything into consideration, just looking at my desk, which doesn't look like much, considering the tools that I have here, you are easily looking, and anyone who knows electronics, you are easily looking, not including the fluke that I use for my test equipment, but you're easily looking at about $250 to $300 worth of stuff. And flux and solder are totally consumable, so that's never ending. So when you factor in, oh, hey, that looks easy, I can do it, just factor that in too. Because if you're going to match all the tools piece for piece, I'm not like other YouTubers in that I'm not going to bullshit you and tell you, oh yeah, you're going to get the same exact results using a Weller. And no, these are all professional grade components. So, and that includes the solder and the flux. So if you want to match apples to apples, always remember to match everything. Because once you do that, that's when you justify, okay, that's why it costs what it does. And that's why I tell everybody, it's the same exact thing. Same exact thing. Okay, so now what I'm going to do is take the fuse holder and we're going to tin our conductors. Once again, I applied some flux right there to that conductor. I'm dropping my heat now on my iron down to 650. Why am I doing that? Because these are tiny conductors and we do not need to burn the hell out of them. We just want them to be tinned. So details count. Clean your tip. Good. Done? You saw how fast that is. That's exactly what we should do. And now what I'm doing, if you notice, I'm balancing the back plate to make sure that that flux pools. The goal is not to have the flux run everywhere. It's to have it pool up. I'm just going to tin it real quick. Done. Now you see why flux is important? Here we go. So now what we're going to do is we're going to take this lead, which is going to lead power from our fuse over to our power switch on the front plate. So what we're going to do is make sure this is straight right here. I'm going to come in and I'm just going to make sure that that lead is straight. Take my time and hold it like this. So you can see there's no fancy tools that I'm using for this. This is just years of practice. The more stable you are, the better results you get. And again, we want to do this as quick as possible because we don't want to excess heat this. On. Move it up a little bit. You can see that tab moves. And the reason it's moving is because we don't have the fuse installed. But it's a caveat because if we have the fuse installed, then we risk damaging our fuse holder as just discussed. So what we want to do is we're going to apply more flux and we work this lead back in very carefully. That's you. Okay, let's see. Let's make sure the angle looks good. That looks awesome. How's that look on camera? I can't see. Are we good? Because you can see the light? Okay. Okay, we're going to hit it one more time. I'm going to do just a sweet kiss. Level this out a little bit. And you notice less heat means that you can work with this a little longer. Teeny bit more solder. That's us. Let's see what we got. There we go. Perfect fill. Everything there is on the money. We'll clean it up. Well, we should be able to clean that right up. In the bottom. We're right on. Everything there looks perfect. So now we've got our tab mounted. Everything there is set. Perfect. Just checking our angles, making sure we're good. Now what we'll do is we're going to apply our heat shrink. We've got 3 other pieces of heat shrink hidden over here. And once again, I stage everything so all of my components are already set. All I'm doing now is final assembly. Heat shrink once again. I put my text out. And you notice I'm angling the heat gun up. And this is why precision heat is so important. I don't want to cook my fuse holder. I simply want to heat the heat shrink. Okay. You do not need to go as low as the base, guys. And what I mean by that, you don't have to bring the heat gun all the way down. You don't need to do that because heat's going to travel. You could stay high and it'll still, that heat will travel down to the base and you're golden. So we're good here. That's awesome. Okay, we're looking good. Now we're going to come over with the big guy. And you notice this longer lead just jumps, boom, right in. So we'll straighten this conductor out. If I need to use heat, I will. And now we're just jumping in right here. And we're right in. Bend over a little bit, a little pressure. Boom. So now I'm going to do the same thing. I'm going to fold this up so that I can get this angle just right. When I say angle just right, what I'm trying to do is keep my flux pooled. Not an easy thing to do all the time, but you work with what you have. You check. Money. Okay. This is why I tell you guys, practice. Practice everything you're doing. When you see a guy drywall or body work, I love watching those guys work because when you see them know what they're doing, everything just falls into place. And they make it look easy. And there's an old saying my dad always used to tell me, when someone makes someone or something look easy, they've been doing that a long time. And that's right on the money. You can see that conductor is centered. Everything there is good. We're looking perfect. Got the right amount of heat. Just making sure that's set, and it is. We will go up. Now, once again, you have to read your conductors. This conductor is right above this portion of the fuse. If this portion of the fuse is heated too much, you will get a stress fracture. So you noticed on the other conductors, I usually did about maybe two to three touches. This I did one. Main reason I did one is because I don't want to overheat this. You've got to read your components. You've got to understand exactly what you're working with. So this is perfect. We're good. And you notice the shrink just goes right over, bring up to the base. I've got a tiny bit of pressure there. Once again, I'm angling the heat gun out of the way. We don't want to cook the base. Come up here. That's you. Now, same principle. Come up here and heat, and you'll see that lead just fall right into place. No stress. That's it. There's your conductor. Make sure that's good. Perfect. Okay, now check everything, make sure it looks good. That's beautiful. We have no fracture. Everything looks beautiful. Now what we're going to do, insert our fuse. Now, on the threads of this, I use a light lubricant. You can use 3-in-1 oil. You can use whatever you'd like. You should always apply a light lubricant on your threads to your fuse. And the reason I do that, you don't want it to ever seize from heat or moisture. And now I'm just slowly inserting it, and it will grab. There it goes. And now we're in, and very, very little right there. That's it. Perfect. We're golden. You can see how clean that is. Immaculate. We're in. Okay. Moving right along. Now, we have two more leads right here. And you can see those are the conductors, and we're going to take our black and our neutral, and we're going to match black to red and neutral to neutral, which is white to white. And that will once again run the power from the rear of the enclosure through a power switch. The power switch, when cycled on, will once again throw power from our live red lead and our neutral and our ground, which will be coming in from the rear of the IC, and that will once again power our system. So I'm going to just set this up real quick.
Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care.
All right, guys, so I've got the Omnivice set up, and you can see, once again, the beauty in this. Soft jaws holding our front plate, and we are inverted. And you notice that we've got the two conductors here, and I've already got this configured. And you notice this is going to be with a single hole, the top of the enclosure. This is the bottom with two holes. When this folds this way, this will put this symmetrical in terms of how it will mount on the base plate. Therefore, by soldering the two leads this way, everything is built properly. If you don't understand what I just said, you will when I'm done. I'll explain it again to give you better visualization. You can see I usually am sitting down when I solder, and I recommend all of you to be comfortable. I'm in a very nice climate-controlled atmosphere. I'm not killing myself. I don't recommend you to kill yourself when you're doing this kind of work. You need to be thinking, and you need to always have everything set appropriately and within arm's reach so you're not killing yourself. Okay, so now what we've got here, I moved the fan over. Here's the first conductor I'm going to work on, which is going to be our neutral. You can see how that lead will come right there. We'll just straighten this up a little bit. And we'll be right there, and you can see exactly where I'm at. Can you see that okay? Okay. If we did this right, this flux will just pool up right here. And we're perfect. Now, one key point I want to make sure that you guys all understand. Make sure to preload your heat shrink. I do that every single time. See it right there? Both leads have heat shrink preloaded. If you don't do that and you do your soldering, you're going to have to go back in and do it again. That little flux right there, we'll take that. Come on in. That iron boot up. Check where we're going to go. And always find that best jigging position with your hand. The more stable your hand is, the better your joint will be. You notice I'm coming up on an angle because I'm trying to clear that piece of plastic, and the heat will let it transfer along with the flux. Just keep heating. There we go. Tack. That's one. We'll hit this again. You can see we've got flux there, and we're not burning it up. It's just sitting in a pool. You can see it right there. And that pool will help that solder flow. Phew. Done. You notice I was using the fine tip of the iron to just come over and make contact with the conductor, just so that we can get heat on that opposite side without burning our separator on our switch. We do not want to do that, or you will be doing it again. In my case, I don't get chances to make mistakes. What you guys accept for yourself is totally up to you. Check it out. That's what you're paying for. That. So now we've got one tacked. I'm going to come in, knock out the other one. Other key point, you notice my leads are all out of my way. With electrical, everything fights you. Most of you guys already know that. Everything will get in your way at one point or another. Make sure everything is tidy. Make your life a hell of a lot easier. Come on in. Same process. Different color conductor. Ready? Apply solder again. And flux. Flux is pooling. You know you did your job right. Everything here is level. That's why the Omni vise is cool, because you can pivot it to make sure you get that back plate right where, or excuse me, the front plate right where you need it. Scratch two. Okay. That lead's a little crooked. I'll straighten that up. Same pooling effect. Now you want to watch, because you've got your right amount of solder on there. And if you're picky, you don't want to add too much solder. We just really want to straighten this up. So I'm just going to come in and I'm just slowly adding more heat by increasing the contact with the tip of the iron. I'll just straighten her out. Right there. Golden. Money. We good? Yep. All right. Done there. Everything looking good. Now we just undo this. And now we can start cleaning up. You notice, we'll lay this down. Now everything with my desk makes sense. Now you know why I worked with the cloth on it, so that we have no marring. Everything is good. Now, before we close everything up, I want to hear in the comments what we should do first. Because a lot of guys would say, okay, you just put your heat shrink on and you're basically done. Well, that would be technically true, other than we haven't tested it yet. So, in order to test it, I'm just moving my multimeter out of the way right now. I want to make contact with my leads. What we're going to do is I'm now going to move this red lead, which is our live out. I have multiple rubber insulating pads here. I just tucked that under. Now I want to state, I'm doing this just to test. With this lead insulated in rubber, there is no contact point here. Okay, and all I'm doing is going to test, and if this is powering correctly, the switch will illuminate after we apply power to it, and everything is set. Now, why do I do this? I test everything before closing everything up, because why in the hell would you close everything up and just test it to find out something failed and you have to start everything over again, removing heat shrink? More work, more time, and that is just asinine to me. So what we'll do, turn our iron off. The beauty of these soldering stations are, they use the same IEC plug that powers the system. So I can come in here carefully, plug it in. Everything works. We should have an illuminated LED. And you can see it for yourself. Now, I always cycle this on a couple times. Make sure there's nothing loose. Everything is acting as it should. So you guys notice that quality is being tested all the way through this system. Perfect. Done. Power tested, mother approved. There you go. So we're golden. Now, we're going to close her up. Right? Because you wouldn't want, like I said, you wouldn't want your doctor putting stitches in you if he doesn't know everything is sound. Leave an instrument in you, it would kind of piss you off. So, same principle. We check everything as we go. And you can see right here, that shrink just goes boop, right over. Next. Got a little bit of flux right there. Come in here. Right, buddy. Make sure we're clean. Yeah, everything's clean. You notice text always on top. Done. Everything level. Once again, power iron back on because I have to steal its power cord, remember? So now what we're going to do, get our leads out of the way as much as possible. Once again, we're not trying to cook anything. We're just trying to get our conductors insulated. Now, most guys that are doing circuit board work know the power of using the precision heat gun for contactless soldering. And if you're doing any type of rework, these precision heat guns are golden. But when you're doing precision heat shrinking on closed components like you see here, they are a godsend because you can control your heat. Nothing is getting cooked. We don't want to make all our work for nothing. You know what I'm saying? That's us. Okay. So now, finish everything up. We're going to come over here. And one question I get asked quite a bit is, I notice the tone on your heat gun changes when you put it back in its holster. And that's right. The reason it changes is because it drops its temperature autonomously by extracting more heat by turning the volume of air going out. So it waits for itself to cool down to a safe temperature to shut itself off, and it extends the life of the unit. So keep that in mind. UAs do that. Now we've got our Estop cable. So now what we're going to do, we've got our Estop terminals already set. Take some deoxit gold, and we're going to come in here and we're going to baste them in some deoxit. We're good. That's done. Take this. Same process. Touch, touch, done. So see, you guys ain't buying that. I'm buying it. Whenever somebody buys a system, they get it just inherently of that. Now, pulling out a secret tool many of you guys may or may not know about. This is a calibrated screwdriver. Okay, 27 NCM, meaning it has a clutch. So when I go to tighten this terminal, it will not over tighten. Listen. Clutch locks, everything is set, you can't strip a screw, and you know you're golden. It also means that your screws are going to be calibrated in even pressure. I'm sure you guys have used torque wrenches on your car in the sense that measuring torque. Now, I made a mistake, see? I mounted this upside down, meaning that our shield drain is upside down. So, very easy fix. I'll turn it over and just swatch this over. There we go. Come on the inside. Come on. Done. And come on this side. That's why silicone is your best friend. So much easier to work with. Done. Done. Now look, ring connector here, kind of like everything matches. Here, everything is set. We're golden. So now we have our front and back plate done. And of course, this is now what I meant when this is in the configuration as it will be with the base plate, not here, it'll be right here. You notice that both screws are the single point screws, meaning this is the top of the box. So everything lines perfectly. Okay. And that is the whole premise. And you notice this is much longer than the base plate of the enclosure so that you can work with it. Naturally, it's attached, so you have to make it a little longer to work with. I've had guys ask me that. Well, don't you ever want to take off the front of the back plate? In theory, the part failure rate of what we just did with soldering is so low. And I mean ridiculously low, pending, of course, you take care of your stuff. This is why I highly recommend keeping your enclosure, because it is electronic in a climate-controlled environment. You will not see high-end CNC factories outside. It will not happen, nor should yours be. And for the price of window AC units, and you can see how everything lays out, there's no reason to have any type of humidity in your shop. It should be clean and immaculate, and you will have a system that will last as long as possible. So again, guys, you can see what our final product looks like. Here, once again, is our live lead, our neutral lead, and our ground that will go to our power supply, and then we are all set. The only thing we will be doing now is mounting our power supply, our fan, and we will then join all the components together and perform final assembly. Hey guys, it's Vince. Today in this video, we are continuing with our G540 build, and we are now at the stage of doing the second half, which is mounting our power supply, our fan, and at that point, we are going to essentially just do final assembly. So what I wanted to show, because many of you are doing this yourselves, is how do you place your power supply and get it set up for drilling? Now, many of you already know how to do this. If you don't know how to do it, this is going to help you tremendously. And of course, this doesn't just pertain to a G540 system. I've already done the mock-up in that I've screwed my front plate on, and before I lock it down, I always make sure, because again, my systems are being sold, I like to make sure everything is square. So I just run my thumbs across, because you're going to feel it much more than you'll see. It's like doing body work. So you just come across, make sure everything is nice and level. Once you're content, you've got the base plate, and you have your Estop already mounted. Now, why do I have my Estop mounted already? Because when I lay my power supply in, I want to make sure that I have proper clearance for the Estop. So again, by doing the mock-up with the Estop pre-installed, you're going to save yourself a lot of headache. That being said, now what I'm ready to do is come in here, and I'm going to lay the power supply just like you would. Figure out, where do I want to put it? And I'm looking for clearance, what I'm looking for. I want to have, about 1/2 inch of clearance on that Estop. That's ideal. Now, I've done this for many years. I already know where I should be. Everything is good. And you can see we have our screw mounting holes for our power supply. Many of you will encounter that already. Before you get to this point, I want to reiterate, the power supply has already been tested. And when I say tested and calibrated with my Fluke 179 True RMS. That means that not only is the unit calibrated for voltage, it's also validated for grounding, okay? Now, in this stage, I'm going to show you once again how the power supply will ground to the base plate and then also ground whatever else is screwed in, meaning parts of the enclosure, to ground the remaining components of the system. So watch as we do this, because I've done this in many videos and I still get tons of questions on this. Just taking our caps off. Watch what we got. Come over. We got tone. Watch. One screw, you can do it anywhere on the power supply and just touch. That's why you want conduction from the power supply. Okay? This power supply is grounded. Now, if I hit the ground terminal on the power supply, and if she shoots right here forward, you can see the ground terminal, everything is grounded. That's what you should have. Okay? So as you're going through assembly, not only do I power test the power supply first, and the reason I do that, many of you already know, I don't want to go through mounting everything and find out that I have a turd of a power supply. That's not going to be good on anyone's account, especially with the amount of time that it would take to redo all the work as far as uninstalling the bad one and reinstalling a new one. Check all of your components prior to assembly. Okay? And that's a professional tip. And why I call it a professional tip, most novices just say, I want to assemble it and be done, because it's a mental overload of sitting there and testing everything and then mounting everything. The slower you work, slow is smooth, smooth is fast. I cannot emphasize that enough. The military did not just come up with that phrase. There is science behind. So again, keep that in mind. Now, power supply, once again, is correlated to proper location on our enclosure. Everything here looks good. What I like to use, if I'm mounting certain components, this is a 1/16 drill bit, and it's just on a pivoting handle. So I just come in here, make my marks. Once all the marks are made, I will then come in, pressurized center punch, so we don't have drills that walk, and we are set. Now I'm going to do this off camera because, again, there's not much for you to learn here. I'm just naturally going to make my marks within the holes, and we'll go on from there. It's much easier than her standing here and holding the camera, and she'll be in my way more than anything else. So I'll cut from now, and we'll go back in, and I'll show you exactly what we got. Okay, guys, you can see I've drilled all the holes. These are all chamfered, nice, so there's no burrs. And now we're just going to come over here and pop our power supply on. Everything is set. And by doing the templating using the front plate, mounting everything in a mock-up form, now I know I have proper clearance for the front plate to be installed, and we're golden. I'm just coming over here and installing some screws. Now, let's cover basics, because many guys already know there are a lot of vendors online that sell G540 systems. And I have seen some horrific ways of mounting power supplies. I use a nut and bolt combination. I've seen vendors use zip ties. I've had vendors use, believe it or not, hot glue. I have seen everything used. I have seen everything used in this industry that is as concocted and asinine as you can see. This is my preferred method for simplicity and alignment. It works really well. And that's it. I don't think I have to explain to you, or shouldn't have to explain to you, why I prefer to use this method. But if you guys want to know, it's because it is the safest method in the sense of impact. When these units are shipping, and some of them do go overseas, we want to make sure that our clients receive the unit in one piece. Something else that I get asked a lot is these units are switchable from 110 volt to 220. If you are an international client of mine, it will be switched prior to shipping. So out of the box, your system is ready to go, minus the fact that you will have to set yourself up with the proper conversion plugs from US to whatever part of the world you're in. That's a fact. So another key point, you can see the 10 V positive and V negative power output terminals on my power supplies. Many of you already know why I do this. On a G540 system or the SMCU integrated system, you want multiple power supply terminals to supply any accessories you go to hook up, so it will prevent daisy chaining in the event you hook up as many accessories as the G540 supports, which is 4 inputs and 2 outputs. So if you think about that, this saves you a bunch of time mounting terminal splitters to avoid daisy chaining. It's also the only power supply in its class that has a built-in EMI filter. So keep that in mind when you guys are checking things out. And once again, and I say this in all my videos, or should be, is that all of my units are available to be purchased in my eBay store. So you just have to go over there. Now what I'm going to do is take the front plate. All of my bolts are loose, and I'm going to apply my front plate. Now many of you already know why I'm doing that. Take 2 screws and do the mock-up once again. Done. And done. There we go. So I got this loose now. I can slide it around a little bit. And the goal here is to get alignment just right. Tighten it up just a little bit. Done. Run my fingers over. Now I like doing this probably about 3 times, and I'm just picking. Everybody else is different. Your system, you can do whatever you like. When I sell something, I sell it the way I would expect it, and that most of the people in the country and the world would accept that, no other. So good. And I feel for deviations. Anything that's off, I can move it back, I can move it forward. And this is just using just slight pressure. And why I'm doing this, because many of you are saying, well, that's the mock-up front plate. Why are you concerned where you mount the front plate? Because when I mount my plate that will be carrying our power to the unit, if this is spaced properly to the power supply and this is level, the next one will be as well. So everything there is pre-measured, so to speak. Okay. So now we can see power supply's in, everything is set. I now tilt the power supply back because then gravity is going to push the two mounting points on the power supply into our front plate, which will give us perfect alignment. I use an open-end wrench, and we're good. Why do I use an open-end wrench? It's just something I prefer. You use whatever you like. Open-end wrench is the nice part is you really don't scratch much. You can use a socket. I've had guys do that. Just depends on what you want to do. And again, these bolts do not need to be ridiculously tight because there's 4 of them, number one. And number two, the compression factor when you bolt something in is very, very different than when you're just screwing something with threads. So now what I do is I check the front and our gap back here. I don't know if you can see that in the light. I just look and see how my gap looks. Everything there looks perfect. I can come over here with a pointer. Back there looks perfect. That's what I'm looking for. That looks good. Now I'll come over to the front, dismount the front plate, and then I can mount those bolts in terms of tightening them. Once that's completed, now we're ready to go to the front plate. That is not the mock-up, is the actual front plate of the system. Get this out of here. Come over. Good. Yeah. And done. Okay, now what I'm going to do is I will grab my front plate, and you can see now my power supply is fully mounted. Nice and clean, everything looks good. We're all set. I'm going to add the front and the back plate. I'll come back over and we'll cut the video right here, and I'll come back over and show you exactly what we're going.
Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care.
All right, guys, I saved you the effort of watching anything that was redundant. I already mounted the front plate. Now, this is no longer the mock-up front plate that we began with. This is the finishing front plate that's already pre-wired. Okay, so you can see here we've got our Estop cable coming in. Now everything is starting to make sense. You can see where our ring terminal will go. I'm going to just remove this bolt right now, and I will apply some deoxit here. Now, some of you may be saying, well, why did you not just leave that bolt out to begin with? Well, that's my preference. I'm a little weird with certain things. I like to just do it and make sure that everything is square, and that's why I really like to apply all bolts, simulate everything. Applying a little deoxit here, a little bit to the ring connector, and just so everyone knows, all of the terminals on a power supply for power in, they are already treated as well with deoxit. Now we have deoxit here on our ring connector. We're just going to come over here and this bolts on. And that is our shield drain, as you've already known because you're watching this video carefully and understanding where everything goes. And this is now going to be grounded because we've already confirmed that we have ground from our power supply to our enclosure, and this grounds out to the base, and everybody's a happy monkey. So what I'm doing right now is I'm just tightening everything, and before I do, I like to make sure that I have everything square. Because, see, it's going a little to the right. So we'll just come over here and loosen this guy up a little bit, make an adjustment till we get everything just nice. And once again, like I said, I'm picky because I present my stuff, and I believe when you buy something from anybody, if it's supposed to be crafted and done by hand, then you should take your time and do it right. That's just me. Everybody's different. I've seen guys have crooked connectors, and seen, like I said, some terrific examples of great work, and I've seen some horrific examples of work. So we try to separate ourselves, you know what I'm saying? So right now, just got to come back a little more. Just bear with me. Done. Done. There We should be golden, and we are. Beautiful. So we're looking for that connector to be square, everything 90 degrees, and we're set. Now, what we're going to do, you notice how everything kind of falls in. We have now this, the tin braided copper comes in. I've got my wire ties here. I've already applied wire tie hold downs, 3 of them, in fact, to the power supply. Just going to come in here. And I think many of you that are looking at building a CNC controller for the first time, I want you to watch this video carefully, along with all of the other G540 videos in this series. And I also want you to watch the SMCU integrated controller as well, because now you're getting an idea of just how fast this is to build in lieu of doing an individual drive system where we're dealing with all those individual drives that need to be wired. All of that crap is gone. So you see the difference in using an integrated drive system. Get that right where we want it. You can see we've got now our 2 silicone leads. We have one short and one long. I just fish it through. Everybody's happy. We're going to come over here now, and you can see exactly what we've got here. Leads look good. Everything looks good. Grab our flush cutters and trim nicely. So now our Estop is now in its home. We have our shield drain wired as we should, and now we're going to start terminating our leads going to our power supply. V negative is in the front terminal. And this is for our Estop. I'm going to come over here and done. And actually make sure, because I can't see if there's any in there. But I always like to go in there. If I don't see any deoxide from when I did it before, I'll add a little more. It's not going to hurt. So it's just easier to do that. If you do have any flux on your connector, you can just wipe it off because it'll usually crust off. In this case, because I've just put deoxide, I'll just use a little bit of flux remover. I don't want the flux remover naturally to counteract our deoxide. There we go. This out the way. And we come in. Once again, much easier. There we go. So our Estop is hooked up. This will go to the G540 on what terminal? If you guys are paying attention, you should know terminal 10 on the G540. So right now, V negative front terminal, boom, there we go. Shield drain is allocated, everything nice and neat. So next, now we've got our fan. We're going to apply our fan. And this is my own fan. It's usually got about 100,000 hour life we're running. And again, I use a 3D printed spacer. And this spacer just comes up here. We mount the fan like this. And then I use some 3M, 3 overlay, meaning I use 3 individual pieces stacked upon each other. And I use double-sided industrial tape. Now, why do I use industrial tape? And for that matter, double-sided tape in general is because it makes the fan mount temporary, number 1. Number 2, the foam acts as a vibration insulator. So if you think about it, it's real easy to remove. It's not something that's super permanent. And then on top of that, you get vibration insulation. And then on top of that, by stacking 3 pieces in correlation, we get the proper height we need. So once again, we're not trying to mount the fan with brute force. You can damage these naturally. I use a 2-inch screw, come in, give us proper spacing so we do not suffocate the fan. And then we're just going to come over here and tighten it up. Careful, right there. Once we get it snug, we'll then place it to make sure that we're square. I'm doing this just with my finger to give you an idea of just how much force I'm actually using. Once I get placement, come in and press, and that will give us our fan right in. So everything there is nice. You can see we got a little space off the bottom. Everything there looks nice and square. And now what we're going to do, because we do have some vibration on anything that rotates, especially at the RPM this does, which is 10,000 RPM. You can see I've already cleaned our wires up, tinned, and everything here is set with heat shrink, so we've got a nice application here. I'm just going to grab a wire tie. This way we can go over the entire process, how we do this. Now I trim my wire ties. Now why do I do that? Because I like them to be clean. Not big on a mess. If we can keep it clean and make it symmetrical, let's make it symmetrical. Everybody's different. So feel free to do as you will. Cool. We're good. Try to keep the crumbs out. We're set. Come over here. Nice and square. Kind of looking like it belongs, right? You guys have seen many of my videos of my systems, and now it's starting to make sense as you see it come together. And once again, keep your area as clean as possible. I try to keep maybe 3 tools, maybe even less than that. Now what we're going to do, we're going to come over here and we are going to get our fan hooked up. So once again, see if I can get in there. There we go. Done. And now we just come in. Once again, guys, I'm using electronic screwdrivers or electrical screwdrivers. These are actually very small. And again, I'm not using a ridiculous amount of torque. Once they make contact, that's about it. Done. Now you see. You can see how the fan then just wraps around. So now what we're going to do, take another wire tie. You see how easy it is to build when everything is laid out. Good. Good. Trim. As clean as possible. Can't see. There we go. Okay, looking good, right? So now what we're going to do, once again, I'm going to come in here. Final tightening, very easy. Done. Come in here now with some Loctite, because the Loctite will go in to those threads. Watch this. Tilt it up on an angle. Just a teeny drop. Boom. You can see that right there. Golden. Like I said, you know, it's what you don't see that it's hard to appreciate. Watching this assembly and dealing with a system that is not an integrated drive system would be a nightmare. This is your wiring, guys. This is it. I mean, think about that. Think about what you're seeing here. It should be opening your eyes, especially I know it does to many of my guys that have already built an IDS system. And that's where things get crazy. You notice I'm cleaning up as I go because right now this about wraps everything up. What I am going to do, power on my heat gun, and I mold the heat stroke where I need it. Done. And now you can see when I wire everything else, it will come in. And these will all get tied, of course. But you see how neat this is? It's like I said, when you actually look at how minimal the wiring is, it's much less invasive than what we see with those individual drive systems. Come in, here's our live. Come right here, done. And I'm anal about how much exposure I have with my leads. Casing should be matched up right to the terminal. Should not be any, or very little, like less than a millimeter of casing that is not going to be up to that terminal. So we're golden. Just do a quick measurement, make sure that looks great. Done. Done. Now when I actually get them set, just enough tightness, then what I'll do is I'll back off. We actually need another wrench. in. Done. And we're torquing them. Done. Once again, just use an extension, different bit, depending upon what you're tightening. Once you use these guys, you don't look back. Everything there looks good. We'll just clean that up. And now, anything on the edge, lead should always be clean. And that's just from handling. And now you can see we're starting to come together. Here's our ground. G540 gets mounted, everything then comes in. And now when you see the front and the back plate attached, you notice how extra I have so that we can work on this. Now I can pull this out, I can work on it, and then I can screw everything in, and I'm done. So now to finalize this, clean up, grab one more wire tie. Now this, of course, I want to state this because many of you already know, this is a basic G540 system. Why I say it's basic, of course, is because it just is for the drive itself. You don't notice anything I'm installing like a relay or multiple relays. That's where more work is entailed. Now the question is how many of you need that? And I get questioned all the time on limit switches. Are they required? And you have guys that want to use them, and then you have guys that'll try my method of using soft limits, and they usually don't look back because they're much simpler, much cheaper, and they're way more accurate than these switches. So the question is, what accessories do you want to add? Believe it or not, the G540 will accept all of the remaining accessories that can be expanded by this system right here in this space. So this is a 12-inch enclosure, and you can see all this space right here. So for the relays, if you wanted to add them, you could add them. Okay. The question is how many of you need them? How many you want to add, one or two, depending upon what application you're dealing with. I get questioned all the time on guys wanting me to give them a quote online, asking me about what I feel they need. Well, the question isn't what I feel you need. The question is what are your applications? So when I tell you, let's have a consultation, some guys will say, well, I don't want to pay you to have you sell me something. Okay, well, would you rather me sell you something blindly and overcharge you because I don't know what you need? Because I can tell you right now, G540 systems, just so you know, because there's no smoke and mirror games with me, I'm going to just tell you how it is. You can go on my eBay store, nothing is smoke and mirrors. The base system with 300-ounce motors, what, 768 plus shipping?
7 something.
Yeah, 7 something with shipping. When we start getting into elaborate systems with dual relays, and we're doing, more elaborate setups with inputs and whatnot, you could be at over $2,000 with labor. So the question is what do you want to do? And if you'd rather not talk on the phone and you'd rather just say, well, I'll just tell you what I want. Okay. I've had clients do that. I know exactly what I need. Beautiful. Tell me what you need and I'll build it. How about that? If I don't know what you need, then we have a problem. So that's the big thing, is just understanding that. Right now I'm just using a spacer, a flat spacer, to put my other wire tie, which I'll use for the switch wiring. And you can see this box is ready for G540. Now I also offer this in a bare bones, and in essence, this is the bare bones. The only difference is I would screw the back plate on. Screw the back plate on, do all the wiring as far as wire tying, and that's it. So what you guys have just seen in this video series, as well as the SMCU, is how fast integrated drives streamline the process of building your CNC controller. When guys want to hit the ground running, these are the systems you should be focusing on. First of all, the G540 comes with a 3-year US warranty. It's excellent. Marcus at Gecko Drive will virtually take care of anyone within that time period. I've worked with him now well over a decade. And I'm telling you right now, as far as consistency, their performance are pretty much unmatched. So it's really a question of what you need. If we have to go bigger than this, the SMCU is going to be your best bet. And again, a drive created in Europe, I don't have to tell you about European quality. I shouldn't. But realistically, these systems change the game. Now what I'm going to do is end the video here, and now what we're going to do is finalize the system by installing the G540 when it has its heat sinks attached, and we will complete the build. Thank you all. Hey guys, it's Vince. Today in this video, I'm continuing with my G540 build, and it just so happens, and this happens quite a bit, as I'll be building to basically back build for inventory. I like to keep one system on the shelf ready to go, and it's just usually a base G540 system. I don't usually have more than that on the shelf because naturally it costs more money to back build inventory. Put it on the shelf, it costs you more money. Therefore, as I was building, I actually sold the system I was working on. Now, that being said, the same build I was working on is right here as far as the power supply and the fan, but you'll notice this client wanted the Master Edition enclosure. And I get asked all the time, what is the difference between the Master Edition enclosure? Well, the difference is that your GX16s are all put into the rear of the enclosure so that it will support all of the G540's inputs and outputs. And in this case, we have 4 inputs that are GX16 3-pin panel mount. You can see them right there. They do come with the dust covers, which also protect against any potential risk of contacting those pins. So these are not just dust covers, they also keep any type of metal objects out of the way that could actually short out your inputs. That being said, this panel also comes with one GX16 6-pin panel mount, which would be for relay control as far as for spindle manipulation, as well as PWM control. Now on this side also, we have another GX16 3-pin if somebody was to install another relay, let's say for a plasma system, or to have another relay installed for cycling direction fore and aft, which you've seen in previous videos. In that case, we would have to decide how we want to do that. We could either use the 6-pin or we would use a 3-pin in conjunction with the 6-pin. Typically, you'd use the 6-pin, but either way, this enclosure is set up so that all of the harder work is done. And you can see right in the back how we have all of our clearance. And look at how short the wire runs are going to the drive. Okay, the longest wire runs are right here. And again, we would use a ferrite with proper filtering as far as the frequency in order to eliminate any potential EMI for passive filtration. This right here is without a doubt the best investment for anyone wanting to eliminate any type of work moving forward. Let me explain. This client, you notice none of these are wired. This client wanted this in case he decides to add any other accessories that the G540 supports. I always tell you guys, check out using soft limits first before putting in physical switches. If you get the results you want with soft limits, guess what? You saved all of that money. However, if you decide that you want to put in physical switches or a touch plate or whatever other accessories the G540 supports, guess what? All of these ports are set, so you're good to go. This is why paying attention and having a consultation with me pays for itself, because this client then doesn't have to worry about machining a standard backplate because all of the work is already done. Again, paying attention to detail is everything with engineering, everything. So I'm going to finish assembling this system because there's no reason for me to work on a system that isn't sold already. I'll get this front and back plate out of the way. This is the one that was originally mounted on this base plate with the power supply. And then I'll have room to continue. You'll notice I have my power leads that are silicone 18 gauge for our G540. Another key point you're going to notice, all of my 540 systems come with a terminal block allocation sticker. 1 through 4 are your inputs, 5 and 6 are your 2 outputs, 7, 8, and 9 control your VFD. If the client decided to do that, that would be once again for PWM manipulation for 0 to 10 volts, equivalating to 0 RPM all the way to 100% RPM. And then of course, 10 is Estop, 11 and 12 are our power leads right here. And that's it. There is no confusion. One half of the cooling system is here, which again, we're extending the mass of the G540 with thermal adhesive using heat sinks. And then we have our cooling fan. So once this mounts, this will naturally have the cooling fan blowing right over our fins. You can see exactly what we're doing. Very simple. First thing we're going to do is grab our deoxit. And we'll come over here. I'm going to knock out hitting our terminals for our client. And then we'll be prepped so that we can get this system where it needs to be. Now he's protected. Proper screwdriver. Once again, there's no guesswork. If you guys are servicing your system yourself, if I don't know, for instance, where my black lead would go for V negative power input to the G540, I can just refer to that terminal block sticker. Come in here once again. You notice I'm using a flathead screwdriver. Why is that? You know what flatheads are used for, guys? Low torque screws. Flathead. You don't need to use a Phillips on any of these. Now, I already know from checking the reference point on that G540 allocation sticker where everything goes. And the next pin is pin 10, which will be for our Estop. So now what I'm going to do, stand up, move this over. Okay. Get our Estop in. Come right in here. And the same way I'm servicing this right now for assembly is the same way I would hope my clients would service it if they were going to work on their own system. I always do a slight pull check on the lead to make sure everything is seated. Nice. Now again, these leads are naturally not going to be under any resistance. The main thing is that you're making sure that that screw is tightened down to at least make contact. Now what we're going to do, we got our 2 power leads here. I'm going to come over here, these out of the way. We will lay this down on this end, just like this. And I will come in here. And we will apply a little bit of deoxit to the leads. Okay. Fish that guy underneath. And then we'll go right there. So whenever you guys see flathead screws, just tip, you know that that's a low torque screw. So in electronics, most of the time, you're going to deal with low torque screws. Very, very few screws in electronics, if any, would be considered high torque screws. And that being said, you don't need to murder the terminal when you're tightening down anything. Right in. Once again, very simple to follow the allocation sticker on the power supply. V positive terminals are in the back, V negative terminals are in the front. Everything here is set. Pitch forward. Fold everything in. Silicone will work with you very easily. And we're right there. So you can see how this is falling together. Now we're going to do our ground. Ground lead, same principle. And this already has deoxit on this terminal. Of course, I'm going to change my screwdriver real quick. And I'll come over here with this. Switching over to torque now. Done. Now, some of you may be asking, why didn't I use a torque screwdriver on the smaller terminal block screws for power output? And that's because this is too much torque for that. So again, logic comes into play. I would be better off doing it by hand, just much less tension. And again, that's just basically understanding working with this type of hardware. If you've never worked with it, less is more, and always work with that. Okay, and you can always do the pull test. Like I said, pull test. If it feels seated, you're good. If there's no tension on anything, then there's no reason to tighten down anything ridiculous. When you're working on a vehicle or another type of machine, the reason you tighten down bolts the way most people do is because you're either dealing with vibration or it's under tension, in which case that's required. Working with electronics, it's not. So we're going to come over here now. You can see the entire system is built All we have to do is tie everything. I want you to think about now what I just said when you consider the fact that this is a 4-axis integrated stepper drive system. So all 4 drives are already wired, power supply is already wired, front and back plates wired. He's even got the accessory plate in the back with all the options to add whatever he'd like. Now what I'm doing, clean up, grab our Phillips, and we're going to come over here, 2/4 inch, 6/32. Here we go. Okay. Come over here, we'll center it as best we can. So it looks kind of busy and like a mess. Be transformed shortly. Right here. Beautiful. Good. Good. I always do this, like I said, about 2 or 3 times just to make sure I get everything in perfect alignment, as much best alignment as possible, just doing a field test. That's just me. Do one more. Okay. And I think right now, feeling good. Beautiful. Okay, now what I do is I'm going to come over here and I like to sight in on the enclosure just to make sure that my leads are not under stress. Of course they're not. And I just take a probe and come in here and kind of fold the leads down, because in this case we're dealing with silicone, and silicone will move out of the way very easily. You don't have to do too much. Just touch, move, and manipulate. Done. You notice our Estop cable out of the way. Everything there, beautiful. Nothing is under stress, and that's exactly what we want. Now, we're going to take this with our zip ties and clean everything. And this is where that careful planning and understanding what length leads you need really brings everything to fruition, because your presentation to me is everything, not just for serviceability, but this is what defines that you've done your homework on how your layout is going to be for your enclosure. Now, you'll see a lot of guys using cable guides. If you want to use a cable guide, that's totally up to you. I don't like them personally. They're a lot of work when you're dealing with servicing. And the guys that use them forget about servicing. They seem to want to make things more permanent in their system. Not smart. You want to be able to service your system on the fly. The faster you can do that, the faster you can keep running. Guys forget that. At least the YouTubers I've seen, most of them want to make things real permanent. When you make things permanent, you have problems. Simple is best under most pretenses. Robotics, if you've done it for a while, you understand, many of you are shaking your head because you do understand it, that the idea is to have it permanent to the sense that we are wanting neatness, not permanent in the sense that we cannot service or adjust. If you do that and you work at that capacity, you're going to find life's a lot easier. See what we're doing here? Very, very simple. Main thing is to make sure my leads are out of the way, because I have tied myself in a corner a couple times, but that's where, once again, whatever you're doing, just like whatever you guys do, that's where your experience comes in. Those mistakes are not mistakes, they're a learning curve. And the more you adjust to that learning curve, you adapt and overcome, right? Like the military. And that's exactly what you're supposed to do. Learn. Never stop learning. Test everything. Believe nothing. Very simple. Very simple. There you go. Okay, see everything getting now pretty much where we want it. Coming in, I try to center everything. Once I get everything in its place, I'll show you what we'll do. Well, actually, you know what? We'll trim these now. This way, clean this up a little bit. Starting to look like a system, isn't it, gentlemen? Done. Same process. Usually when I'm tying, I like to stay with a wire tie first, meaning wherever the hole down is, I'll actually tack it with that first. Leave a little slack in here because these leads can be adjusted then. And nice. Now you'll notice these leads, and you guys will go through this yourselves. These are not silicone. These are just straight up 16 gauge leads. And when it comes from the fuse or wherever you're working with, if you find that you are working with PVC type leads, you're going to find that they're not always as flexible as you may like. That being said, many of you already know the answer of how we correct that. The word is heat. We do this very carefully. Never hit anything sensitive, just hit the conductors themselves. And that allows a molding effect. So now I can come in here and these leads that used to be tight are no longer tight. I can mold them any way I'd like, and there's no stress. And this is why I say time and time again, an integrated drive system built correctly is beating virtually every other system on the market, mainly, if not for anything, simplicity. And then on top of that, you have the luxury of servicing the system very quickly, very, very quickly. Come in, do final heating on this then. Right there. We're golden. That's beautiful. Okay. And you'll notice the leads still want to fight me a little bit, no worries. Be very cautious when you use your flush cutters that you do not cut, God forbid, a line. I've had clients tell me they've done that and they're moving really quick or they're working late at night. I tell you guys all the time, do not work when you're tired. Not best practice.
Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care.
Done. Now, get everything basically where you want it. Now I go precision heat because now everything's tied. That, in fact, you don't need a lot of heat. You really just need them areas that you want to concentrate on. Perfect. That's us, boys and girls. We're golden. Yeah, one more up here. Take it. There we go. I want you to go online, do some research, and see how many 4-axis systems are wired that fast and tied to this level and cleaned in that speed. This is all real time. Think about what I just showed you. Yeah. Golden. Every now and then you get one that just sticks up. It doesn't want to be friendly. Okay. Clean everything up. And we're golden. Okay. Now we're all tied. Now for the next step, I'm just going to get my desk cleaned and it will be graphical time. So final step on this is graphics power testing, and that's it. Right, guys, I've just gotten done putting on all of our servicing graphics. Once again, these are not put on just for show. These are put on to, once again, help the client. Clean fan biweekly for optimal cooling for performance. Once again, I have certain clients that do that. I have other guys that I'm sure don't. I'm not putting this on there for my health. Believe me, I'm doing extra work doing that. It's costing me money. The reason I'm telling you to do that is to make sure that, once again, that fan does not ever get clogged with sawdust and other types of debris, dust, so on and so forth. Please review the user's manual and all email supplied videos prior to the system's operation. Naturally, that's self-explanatory. Read and review every piece of documentation, whether it be a video or documents that, once again, pertain to the operation of your controller. Spin it around. Once again, Gecko drive information, you've got it here. We've got it on our power supply. Main USA quality validated. Once again, we're going to go through this. I'm going to plug it in now. We'll do a full power test on it. We've already done a grounding test. IEC cord coming out of our soldering station. And I just go over everything for sanity. Sanity check, live neutral ground. Take nothing for granted, and that includes myself. And we're perfect. Looking good. And that's on. And I'll let her come over here. You hear our soft start fan? Green light, engage fault. Disengage fault. And I do this a couple times to make sure everything is set. Okay. Power LED on the power supply. Not really necessary when we get a fan kicking that much inlet out. Multimeter goes on. Switch my leads underneath. Checking voltage now. That's perfect. I always calibrate mine to 48.5 with golden there. I've already tested this power supply beforehand. I just do a quick test on all reads. Just making sure everything is good and nothing has changed. Cool. Checking grounding. Once again, power on. Perfect grounding. Everything looks great. Switching over now to 110 so we can check our auxiliary. And that's it. Now she's fully tested, LED in the front, everything here is functioning as it should. We'll check Estop one more time. We're perfect. And that's it, guys. Now, of course, this is still a base G540 system in that none of the accessory ports are connected. In the event you were to order this system and you wanted me to wire in all the accessory ports, well, naturally the price goes up because labor goes up. So keep that in mind. Other than that, this system's set. And if you guys are competent enough and you feel that you're okay doing the labor on your end, you can certainly do this like this particular client in the sense that buy the system in this format with all the ports added and add whatever accessories you want, saving all that money in time and labor. So this, once again, has been a really detailed video. I hope you guys have gotten a lot from it. And once again, you get to see exactly how these are built. And you can see what you're left with. Not much. This system is set to go. And best of all, it will take that client from wherever he wants to go and allow him to, once again, add relays, add input should he decide to, and whatever other accessory the G540 supports. And best of all he has to do is invest his own time and, once again, labor, because he will be getting the matching female connectors with these ports as well. That's something I always do. I don't charge you guys for that. If you buy the Master Edition version, or in this case, this is just the enclosure that's considered to have all ports added, and that's exactly what this is. He will receive the matching female GX16 3-pin connectors with this. So he doesn't even have to source them. All he has to do is build whatever cables he requires for whatever accessories he wants to work with. So again, guys, I hope that this video series has been helpful. I hope you guys have learned a lot. And once again, there's no more smoke and mirrors. You got to see the whole process of me doing this right there in front of you, and you see what we're left with. So I'm going to get to boxing this up, putting a lid on and all that. Now, of course, I go and film a video for the client as well. In this particular instance, I could actually just send him this video and we're set because power test and grounding test, everything has been done just as I do for every system. So once again, hand-built systems all the way through and through, from, once again, building the Estop cable, shielding it, to actually testing and confirming each component individually, as every system should be built. I don't care what brand you buy or who you buy it from. This is the process that should be done. And that includes validating grounding and every other port that's on the system that needs to be done. So keep that all in mind. Thank you all for your support. Take care.